at the bottom of this one. This was that force F that is being applied. Radius of the direction of friction should be like this. So center of mass will accelerate and it will have angular acceleration alpha c. You have plenty of questions to ask. Okay, you can ask it. So acceleration of center of mass should be F minus is asking for the angular acceleration. Angular acceleration should be equal to torque, should be equal to I into alpha c, IC into alpha c. So what is the torque? F into R mu k mg into R is equal to, this is like a solid cylinder, no? So mr square by 2 into alpha c. Okay, see no. So the thing is, what is alpha c further? F minus mu k mg by how come? But sir, like a pure rolling hall. Yeah.
Why did you take acceleration in that direction, sir?
If you pull at this particular end, so this is some plane diagram is what I'm showing. So as I start pulling it, no, so it has to unroll, no. So if it unrolls, then only this end length will increase. I think in your home you'll be having a carpet. Keep it on rough surface rather than granite or something. No, keep it on bed sheet. There'll be sufficient friction. So as you start pulling that, this one end here, it has to unroll. If it unrolls only, then only this possible. No, this length will increase. So for if it alpha, if I bring in this direction, then it will not unroll. No, so therefore the alpha should be backward. Should be so like counterclockwise. Sorry, here, not clockwise. Plane diagram, actually I should not draw. So to write equations, I'm bringing here. There's only a plane diagram, just only I'm trying to look at this particular part. There's a carpet here again. As this is a light, no, what force you apply here, that force will be acting at this particular point also. Every roll of wrapping paper of mass m and radius r in the form of solid cylinder is resting. No? So what force I applied here, the same force will be acting here. So therefore the assumption I made it. So if you put alpha like this, so what is the problem? It cannot unroll. Alpha should be like this only. Can be tested for you. Simple idea based here.
Sir,
Uh,
in the previous question, it is given that the carpet is slipping on the surface. So how can we take force F there? The part of the carpet which was unbound, it will have some acceleration. So the force will be something less than F.
this one,
Yes, sir. We are applying force on the part which is unbound, and the force which is acting on the like the cylindrical part of the carpet, that should be less than F, because
no,
that
no,
part
no,
of
no.
the carpet which was unbound will also accelerate.
Actually, it's like this everything is a system. That's what is taken. I took M here. That's what this is just a to write equations I brought here. Otherwise, what happened? That everything will be M, no?
Then how can we write moment of inertia as mr square by 2? The carpet which was unwound will also have some mass.
Some mass will decrease here. So we are just discussing when some amount gets unrolled, we are discussing this problem. Or the question will depend, some half of the length of carpet is unrolled. Okay, then we'll write M by 2 and things will be little bit different here. Then there's M by 2, no? So then F minus the friction on this M by 2A then the tension here will act, that tension will things and also just the moment this will be small length, just is about to unroll, we are discussing the problem.
Okay, sir.
I think the question, I think they have put only this much here. If it were really some length unrolled, then if you're asked no, then that length you will give. When you mention this length, then you cannot think in this way. Then you should bring the mass of the carpet which is unrolled here. Then the tension T you have to bring it. Then F minus T equal to mass of the carpet unrolled into acceleration. Okay, agree this? Then this T what happened should be brought into picture. Got the idea? This is some information. Now try to see this. I think we have, yeah, this will be. As a teacher, I really want to test students with this particular problem. So get into free body diagram. Don't try to, it's not just mere looking. Immediately get the free body diagram. The inclined plane is a fixed one. I think it's there in most of the books. It's there in most of the books. Yeah, this sphere. Okay, let me proceed now. Let me indicate all the forces that are going to act first. MG, both are acceleration of Planck be required to keep the center C of cylinder fixed during motion plane. No slipping takes between the cylinder and the plank. Okay, the weight of this mg sine theta. Acceleration of the plank up the incline, that is A. Then the frictional force. Yeah, these are the forces that will be sufficient. Okay, now we'll get into mg sine theta, acceleration of Planck. There's a direction of friction. No slipping takes place between cylinder and Planck. So directly I'll pick up 2 points, P1 and P2. So what is the yeah. What should be the P1 and P2 now? The acceleration of P1 should be equal to P2. First we'll write some equation. So because of the friction acting, alpha should be like this. To keep the center C of a cylinder in a fixed position. So what should be the acceleration of C? Must be 0. From where this is a given, no? So because of that, I'm writing this condition. If acceleration of point C is 0, then the F should be equal to mg sine theta. F into R should be equal to mr square by 2 into alpha. So this mg alpha equal to 2g sine theta by R. Then no slipping occurs. For no slipping, acceleration of point P1 should be equal to acceleration of point P2. Acceleration of point P1 is how much? R alpha. Acceleration of Planck should be A. That won't given, no? So R alpha should be equal to 2g sine theta. This is our answer. Objective question. So definitely advanced. You may expect of questions of like this. I think the blue color water indicates the acceleration of A of the plank required to keep the center C of a cylinder fixed. Unless you don't write this, not possible. If you consider the acceleration of center of mass, no, I think things will become very complicated. You see that. Thinking based problem, not like something information based, data based. As far as mains, I think in mains they can ask you some small ideas like this, where it doesn't need any integration, or even in advance can be set up. No, so try to work out different set of numericals where some idea will be there. That core idea should be reflected. Pick up problems of that kind, not like a routine type, because now you're at a revision stage. No, so now rolling. Next, what you have is conservation of angular momentum, angular impulse. There are three topics are there. So recollect maximum from the notes. Once you are very sure about the notes, then try to take different books or question papers, what all you have. Try to think on them. Immediately draw the diagram. So don't bother how it is possible 2g sine theta. First, immediately draw the diagram, show all the forces. Then how do they can rotate? How do they move? Carry on. Then condition for no slipping is telling, okay, this one, center C at rest, right? You'll end up. So most of the rolling motion, what happened? First, we must get the direction of forces acting. How do the body will rotate or how do it will move? Then some how many unknowns are there? How many equations are there? Any constraint equation or any conditions for slipping? Ideas has to be introduced here. You have to your preparation should be of both the kinds, mains as well as advanced oriented, not only lengthy problems. I'm making things clear. And parallelly, you are having SHM. So SHM, you start with kinematics of SHM, simple pendulum, compound pendulum, superposition, then springs, then SHM with mixed concept. Like this is, I think 2 days will be sufficient. Just go through different numericals. Only kinematics of SHM will take more time because mass based one. Try to balance of these kind. Okay, we'll stop the class. We'll continue from. Shall I tomorrow do SHM or only this? Shall I continue? Okay, I'll do one thing. Let me first